Hi, today we're going to look at reasoning. We're going to discuss two different kinds of reasoning. This next unit is going to work with logic, and we're also going to look at some linear relationships, so relationship between lines. Today's lesson and tomorrow's lessons are going to focus just on reasoning. There are two types of reasoning, deductive and inductive reasoning. Deductive reasoning uses facts, rules, and definitions to arrive at a conclusion. So for example, we know the definition of an acute angle is an angle that measures between 0 and 90 degrees. So we can use deductive reasoning to say an angle that measures 30 degrees is acute because we're using the definition to come to that conclusion that the angle is acute. Inductive reasoning uses patterns and observations to arrive at a conjecture. Okay? That means we need to stop real quick and talk about what the word conjecture means, because where we know what a conclusion is, okay, a conjecture is also a conclusion, but it's based on observed information, and it doesn't necessarily always have to be true. It can be false. Sometimes we'll get an answer that turns out to not be true, and we'll talk about what we do in that situation in a little bit. Okay? Exercise 1 says to find the next value in each list below. So when I look at my first one, I'm going to look at the pattern, which means we're using inductive reasoning because I'm looking at the pattern. Okay? So 8:30 a.m., 9:45 a.m., 11 a.m., and then 12:15 p.m. Okay? One of the easiest things to do is to just kind of look and say, well, what is the time difference between each one? From 8:30 to 9:45 a.m., I can see a time difference of 1 hour and 15 minutes. So let's see if we get the same thing. From an hour from 9:45 would be 10:45, and then 15 more minutes, would also put that as also an hour and 15 minutes. An hour from 11 a.m. would be noon, which is 12 p.m., plus another 15 minutes. So yes, this is also an hour and 15 minutes. So let's figure out what is going to be another hour and 15 minutes to figure out what our next number is going to be. Okay? So from 12:15, 1 hour would be 1:15, and then I need that extra 15 minutes, so it's going to be 1:30 p.m. Okay, let's look at number 2. Number 2, 4, 10, 18, 28, and 40. So let's see, if I look at how they're changing, from 4 to 10, that's an increase of 6. From 10 to 18, that's an increase of 8. From 18 to 28, that's an increase of 10. So it's not increasing by the same thing every time. From 28 to 40, if I do 28 minus 40, or 40 minus 28, that's an increase of 12. So they didn't increase by the same thing, but is there a pattern in how much they increase by? 6, 8, 10, 12. So 6 plus 2, 8 plus 2, 10 plus 2. So the next increase is going to be 6, 8, 10, 12, and then 14. 40 plus 14 is 54. So again, we're just looking at the pattern and using inductive reasoning to find the next number that we think would go next. Okay? All right, the next one, 3, 12, 48, and 192. So let's see what's happening here. From 3 to 12, that's a difference of 9. From 12 to 48 is a difference of 36. From 48 to 192 is a difference of 144. So let's see. Those are really strange. From 36 to 9, 36 minus 9 is 27. 144 minus 36 is 108. So that doesn't look like something, but I can see when I look at 9 and I look at 36 and I look at 44, there kind of looks like maybe there's a pattern there. Sometimes we also say, well, maybe instead of adding to get from here, from one number to another, maybe I divided or maybe I multiplied. So let's think about what would it be if instead of adding, what if we instead multiplied? So what if we said 3 times something makes 12? Well, 3 times 4 makes 12. 12 times 4 makes 48. Is 48 times 4 also 192? Yes, it is. So it looks like we are multiplying by 4 each time, right? Times 4. So it looks like if I was asked to describe the pattern, I would say multiply the previous number by 4. 192 times 4 is 768. Okay? I also kind of see a pattern here. 9 could be rewritten as 3 squared. 36 could be rewritten as 9 squared. And 144 could be rewritten as 12 squared. So 3 squared, 9 squared, 12 squared, 3, 9, 12. I wonder if we could go back and find a pattern there, right? Maybe. All right, so sometimes there's more than one way to find our answers, and sometimes they'll even give us different answers over here, but remember that's okay because we're using inductive reasoning, just observing a pattern, and our conjecture can be false as long as we have a valid reason for why we think it is, right? We couldn't just put any old number over here and say, well, it's okay because it can be false. We need to be able to say, no, I know I'm going to go with that number because we're multiplying by 4 each time. Okay, so you need to have an actual, be able to back up your conjecture. Okay? All right, so the next one I'm going to look at, 4, 3, 1, and negative 2. This time we're decreasing. I have to decrease by 1. 4 minus 1 is 3. Then I'm decreasing by 2. Then I'm decreasing by 3. So I decrease by 1, then 2, then 3. So I bet you I'm going to decrease by 4 and be at negative 6. Okay? So we've already talked about it, but what type of reasoning did we use to arrive at each value in the exercise? We were looking at the pattern, so we were using inductive reasoning. Because we were looking at the pattern. Okay? Inductive reasoning. We observed a pattern. Okay? Let's see if we can do a little bit more with inductive reasoning. All right, so as we continue focusing on inductive reasoning, we're going to connect every point on each circle and determine the number of regions created. So what we mean by that is if I have 2 points on the circle and I connect them, how many regions did I create? I have one region here and another section here. So it's just like how many sections have we divided the circle into? 2 sections, right? Or 2 regions. Okay? When I have 3 points, if I connect this one here and here, this point can be connected there, it already is, and it can be connected here, and then this point can connect to each one. So let's see, how many, I can't draw any more segments in there. How many regions did I make? 1, 2, 3, and 4 sections or 4 regions. Okay? Let's look at the next one. This point can be connected here. It can go diagonal across the circle, and it can go straight down. If I go to the one underneath, it can go to the one it just came from, or the one diagonal across, or the one here. So we're connecting every point to every single dot. This one can go next door, it can go across diagonally, or it can go straight up. And then this one is already connected to the other 3. So how many regions did I make? 1, 2, 3, 4, 5, 6, 7, 8 regions. Let's look at the next one. So again, each point is going to connect to every other point. So what I do a lot of times is I just pick one and I make sure it connects to all of them. Then I go to the next one and I make sure it connects to all of them. And then I go to the next one and I make sure it connects to all of them. It's already connected to 2 of them. And then the next one, make sure it's connected to all of them. I only have to draw 1. And then the last one is connected to all of them already. So let's see. This is going to get a little harder to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 regions. Okay, so I have 2, 4, 8, and 16, and it wants me now to write a conjecture. So that means that means to look at the pattern and come up with a conclusion that's based on the pattern about a circle with 6 points. So I've got 2, 3, 4, 5. What do I think is going to happen when I have 6 points? So we're going to write a conjecture. Well, let's think. Let's look at the pattern. 2, 4, 8, 16. It kind of looks like it doubles, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I'm going to conjecture that a circle with 6 points will have 32, because I'm going to multiply that 16 by 2, regions. Okay? Go ahead and try that with this circle, and then in the next video, we'll see that we got 32 regions. Okay? I'll see you in the next video.